but don't look down. 'Cause I'm on top of the world. I'm on top of the world. Okay, and so today we're going to look at stem and leaf diagrams, back-to-back ones. Okay, so from back-to-back stem and leaves, we mainly use them to compare two sets of data, two sets that are related. Like if we were comparing the height of boys versus the height of girls in a year group. Okay, from a stem and leaf we can read, well, we know the minimum. The lower quartile we've discussed already, and we call that quarter one. Okay, the median as the middle value, that's the same as quarter two, it's the halfway mark. And so the upper quartile would be quarter three. And then we could calculate the interquartile range, which we'll look at different. And the maximum value, we already know that's our upper limit. Okay, so our first job to do, we see here we're given two sets of data. The ages of the Academy Award winners for Best Male Actor and Best Female Actor. And we're asked to represent the data on a back-to-back stem and leaf diagram. So as we know, a back-to-back stem and leaf diagram is really useful for comparing two sets of related data. And so our first job is to reorder the data. Reorder data. So if I was to do it here underneath with male, well, I can see the 29, that's the youngest. The next that I have is 32, and so on, and I can continue on in this way until I have all the data reordered. So pause the video for a moment and write out the data in ascending order. So starting with the smallest right up to the biggest, so that we only need to fill in the stem and leaf diagram once. Okay, so now that I have reordered the data, then I can begin to write it into my stem and leaf. So beginning with the males again on the stem and leaf, well, here I would have 29, and then I would have 32, and so on. I'll continue on till I have it done. So again, you can pause the video to complete the stem and leaf diagram for yourselves. Okay, so essentially my stem and leaf diagram from my reordered data looks something like this. Okay, I note now the next thing that I need to do is to do the key. So here, picking any bit of information from the key. So here I'm going to do two keys. I have 2 and a 9, and well, that equals to 29. And then on the other side I have 2 and 5, and that is equal to 25, and that's my key. Okay, and so this is what my completed stem and leaf, back-to-back stem and leaf diagram looks like. Okay, so now that we have completed that part, we can use the stem and leaf diagram to answer some of the following questions and to give us information. Before doing that though, let's just have a quick look. If I was to draw a distribution curve here, I can see there's a bit of a tail to this side, okay? And it's at the far end, the upper end of the data, so it is a tail to the right. If you turn your page around, like for example like this, you would see here that obviously it's the opposite side, it's like the mirror image, but here's my distribution, and I can see there's a tail here at the upper end of the stems, which means that there is a tail to the right, which is a positive skewed distribution. Equally, if I turn it back here to the female actors to look at it, or an upside down, so that we would see like a normal histogram or something, what can I see here? That really it's almost a normal distribution centered around the 30s. However, we have one outlier over here with the female actors, and that's at 61. If we did want to say about a skew, again we'd be saying that there is a skewed tail to the right, a positive skewed distribution. And okay, so we're going to look at answering some of the other questions that were asked in relation to the data. Okay, so in question B here we're asked to state one similarity and one difference that can be observed between the ages of the male and the female winners. Now, if I look at my stem and leaf diagram, I can see there's a few similarities. They have similar ages in both, so that the range here is 29, it goes up to 60. The range here 25 up to 61, so we might compare that as a similarity. Similar shape distribution for the most part. Obviously this goes a little bit more. There's a little bit of a skew, but I suppose here the easiest similarity really that we can observe is the range. So we're just going to calculate the range for both the male actors and the female actors. We know that the range is the biggest value, take away the smallest value. So now we can calculate the range for the male actors and the range for the female actors. So our male range, well, that's going to be 60 minus 29, which gives us a range of 31 years. Now our female range, well, that's going to be 61 minus 25, which gives us a range of 36. So the range is similar, okay? The range of ages is similar. Okay, so to examine some of our differences, well, in the females, there's nobody in their 50s. No female in their 50s. There is an outlier in the females. There's one female who has 61. So there are two different differences already. And the other difference then is in the females, they're that little bit younger than the males in winning their leading actors awards. So there's some differences that we could list. Okay, and so here we have listed our three differences. So you could pick any one of those, but certainly pause the video now and make sure that you get those notes written into your example. Make sure that you're taking down the questions as well as you go. Okay, and this is an example of a junior cert higher level statistics question. Okay, here in this question, Mary says the female winners were younger than the male winners. Investigate this statement in relation to the mean age. So here we're asked to calculate the mean of the male and female winners. So I'm just going to bring back in the original data to help me to calculate the mean. Okay, so the mean means that we add all the numbers and we divide by the number of numbers. And again, we know the symbol for mean is x bar, okay? So here we'll say, well, the mean for males, well, I'm going to add all the numbers together. So 54 plus 52 plus 37 and so on until I get, and adding all those together, I get 887 and I divide that by 20. So I get a mean for the males of 44.35 and for the females, my mean or x bar, well, similarly again, I add all together, so 42 plus 29 plus 33 and so on until I get a total of 714, and I divide that by 20 and that gives me a mean age of 35.7. So Mary had said that the female winners were younger than the male winners. Well, in terms of for mean, that is true for females. Okay, that statement, true, females are younger. Okay, true for mean. And let's look at it in relation to the median. Okay, so we have to investigate it again, this time for the median age of male winners and the median age of female winners. So are female winners younger than male winners? So again, I'm going to bring back in something to help me to calculate the median, and that will be the easiest way to do it is to go back to our stem and leaf. So I'll bring in a copy of our stem and leaf now. You can also pause this yourselves right now and calculate the median of both male and female using your own stem and leaf diagram. So in order to calculate the mean, well, I begin with my smallest number and I work my way in. So here I'm going to have 29 for male and 60, and then the next smallest is 32, my next biggest is 60. My next smallest is 36 and my next biggest is 54, 37, 52, 37, 50, 38, 50, 38 and 48, 40 and 47, 43 and 46, which leaves me with two numbers here in the middle. So my median for males, well, I can see very clearly what it is, but just to display, it's going to be 45 plus 45 divided by 2, which is equal to 45. And so let's have a look and investigate our median age for female actors. So again, we'll start with the smallest, so that's 25, and our biggest is 61. Our next smallest is 26, and our next biggest 49. 28 and 45, 29, 45, 29 and 42, 29, and our next biggest being 39. Next 30, 36, 32, 35, 33 and 35. And so for females, I'm left again with two pieces of data in the middle, and I expect that because I know I have an even number of data. So again, I can see quite clearly that it's 33, but just that I get the average of both of those, or the mean. So 33 plus 33 is 66, and divided by 2, well, that gives me 33. So again, Mary had said up here that the female winners were younger than the male winners. We saw in the last part that it was true for the mean, but here we can also see that it is a true statement for the median. So true for median, and I'll just put a little tick there to say that it's true. Okay, and so this is the new part for us. We're looking here in this part of the question at the interquartile ranges for the male and the female. Okay, and so the interquartile, well, we know the range is the difference between the biggest and the smallest. We know quartile, it looks like quarter. So essentially what we're going to do, we're going to divide our data up into quarters. We know the median gives us the middle value, and so we're going to get the median first, and then we'll get the median of the medians. Okay, so we want to split our data up into quarters. Okay. So just bringing back in my stem and leaf where I worked out the median, well, I can just very quickly see that here's the median, this point here in both sets of data. And so I'm going to call that Q2, or well, we'll even just call it our median still. Okay, so that's the median just there. Okay, so now that's the halfway point. From here all the way up to here is 1/2, and from here, and this is my second half. Okay, so essentially what I want to do, I want to get the halfway point of that. Now I can see if I go here, I've 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So well, what would be halfway between those 10 pieces? Well, 10 divided by 2 would give me 5. So I know I want to go in 5. The only problem here is, again, I'm going to have an even number. So really the easiest step for me to take is to go and just calculate the median of the medians. So here I'm going to go in black pen this time, and I'm going to say, well, my biggest and my smallest and my next biggest. My next biggest and my next smallest, my next biggest and my next smallest, my next biggest and my next smallest. So my male Q1 for my males is going to be equal to 37 plus 38 divided by 2, which gives me 37.5. So that's for Q1. I'm going to do the same process for Q3, my upper quartile. So quarter 1, and now I want to work out my Q3. Okay, so here I'm going to work away. I'm going to do it in green this time. So I'll begin with my smallest here, which is the 45, and my biggest is 60. My next smallest 46, my next biggest is 60. 47, and my next biggest is 54. 48, and my next biggest is 52. And so I'm left here with 2 in the middle. So that's Q3 is equal to 50 plus 50 divided by 2, which is 50. So I can see here then my IQ, or my interquartile range, is going to be equal to Q3 minus Q1, which is 50 minus 37.5, which is an interquartile range of 12.5. Okay, now they ask us to do the same for the female winners. So pause the video and see, do you calculate the same interquartile range that I do? So just do it for yourselves quickly now. So the median of the medians is essentially what we're looking for. Okay, and so very quickly I'm going to go through it. So my smallest is 25, and my biggest before the median is 33. My next smallest is 26, my next biggest 33, next smallest 28, next biggest is 32, 29 and 30, and that leaves me with an Q1 for the female actors. Well, that's going to be 29 plus 29 divided by 2, which gives me 29. And then I will do the same for quarter 3. So I begin, the smallest value after the median is 33, and the biggest is 61. The next smallest 35, next biggest this 35 again, next biggest 45, 36, 50, 45, 39. Oops, sorry, I'm left there with my 2 in the middle, so 30 and 42. So Q3 here is equal to 39 plus 42 divided by 2, which is 81. And so divided that by 2, well, that gives me a Q3 of 40.5. So the interquartile range for the females is going to be again Q3 minus Q1, which is 40.5 minus 29, which is an interquartile range of 11 point, whoops, 11.5. Okay, so that's our two interquartile ranges calculated. Okay, so that's the last part of our question. So pause the video, make sure you've all the notes taken down into your copy, and now you can do the learning check, which will be another example of a stem and leaf back to back with an interquartile range needed to be calculated. Okay, so here we have our learning check. You're given the stem and leaf data, the diagram, so copy it into your maths copy and then answer the questions here on the right. So pause the video, copy the stem and leaf into your copy and answer the questions.